Okay, and I'll upload this later on to where we're going to be keeping track of information. Let me change the share to where I was before, which is the other Google Chrome. One sec here while this one changes for us. Here we go, share, how's that? Okay guys, so there you go. Okay, so for some changes for this week, the Google Classroom's way we're going to be doing everything. Has everyone found the invitation and you see there's stuff on Google Classroom? That's where all the information is going to be posted, okay? No more veer across for now. Just because I think Google Classroom, well, the time that I set it up, it was the easiest way in which for you to hand things in, okay? And having said that, I'm not going to be collecting the homework each week. I just want to see a daily progress of homework. So when you complete an exercise for the next day, hand it in. Don't worry if you didn't get 2 or 3 questions and I'm going to correct them at a different time. Just show me that you're participating on a day-by-day basis. Like Vinny, we didn't see him today, and I want to make sure that he's done something. So by next time, I want to see his homework submitted. Is that good?
Yeah.
Okay.
Yep.
Now, homework help, use it. Okay, and I've changed the format a bit. So you'll notice it's opening up here for us. I've got a column where you're going to put your image, but I really need you to put the exercise set now, because I'm not going to copy and paste these and do them on the screen for you. I'm going to create videos when I can and put links to the videos here. So if we don't know the question number, it just makes it confusing for everyone, okay? So if it was question number 1C, an exercise from Oxford 2H, put some description over here, take a picture, and then I'll make a video of the solution. Okay, is that good?
Mm-hmm.
Any questions there? Okay. So other little bits before we get going. There's a weekly schedule. Oh, I didn't paste it in here. So let me show you the weekly schedule. I emailed it to everybody, and you should get it.
Yeah, I saw it on the email.
Yeah, you should get it each week. I'll send you one again on Sunday so you know what's coming up, because I know that it is quite a lot here. So let's take a picture of this here. That was supposed to go in our Google Doc there, okay? So it looks like, just so you can see how this is gonna work out, I'll move this out of the way here. We're gonna be doing these Zoom chats 3 times a week, okay? And so we'll do today, we'll do Wednesday, and we'll do Friday. I know today's only 45 minutes, but I don't wanna go all the way from like Friday to the next Wednesday without talking with you guys. So we're gonna do Monday, Wednesday, and Friday, okay? In the other times when we're not meeting, those, you can treat those as office hours, okay? So on Thursday, that time I'm here for you, okay? I don't know if I'll send out an invitation or if you email me, but we'll do a chat if you need some extra help with the homework. Or maybe you missed because you're Vinny and you slept in or something like that. That's the time that you can catch up. Is that clear?
Yeah, I have a question.
Yes, sir.
Homework for Wednesday, do we need to do them before class or after? Like,
You could submit it before class, so I know you've done something. That's great. If it's not complete, Mateo, don't worry about it too much. I'll be pretty relaxed about that. Okay?
but always before class. It's not like the homework like after the class.
No, try and do it before the class so I know that you've done something. Yeah, it
Wait,
means
so-
if you handed it in after the class, that would be better than nothing at all.
The notes are homework though, right?
So yeah, so the way this is going to work, it's going to be kind of a flipped classroom when possible. And so what that means, Nadia, is I'm going to try and do a video of the kind of notes, like, and they won't be long, 20 to 30 minutes that you can watch before. And then the time that we spend together, you can ask me about the notes or ask me homework questions that you couldn't get, okay? So we'll kind of try that out. So that's why they mean flip, because typically you come to see me and I give you the notes and then you go home and you do the homework, right? This way we'll try and flip it around. So at home you can watch a video and then we're together, we can discuss a little bit of the things about the notes you didn't know or homework questions you couldn't get. Sound good? Yeah? And so the 3 Zoom meetings and the other meeting is going to be a flipped classroom. Good?
Sir,
Yeah.
like the homework on Monday, like rates of change worksheet, is it for today?
Yeah, I'll show you. So if you take a look at the Google Classroom, this is your Google Classroom here. Can you guys see that? Yeah? Okay. So this is a stream, but if you go to the classwork, Ludovico, you'll see what I'm going to do here. So I scheduled for March 18th, this homework here. So you know this is due for Wednesday.
Oh, right. Okay.
Yeah? So you can just
Yep.
go like, just forget the Veracross calendar. I'm not going to put stuff in Veracross. We'll just put it in here. All right?
All right.
And if you guys could do scans rather than take pictures, that's a little bit better. Okay? The pictures don't come out the greatest. So you can download an app onto your phone or your iPad that takes the picture and turns it into a PDF.
Mr. I think Notes does that. That's what I did yesterday.
It's like, you know, the HP Scan, the app. It's actually quite good.
Yeah, that's right.
Notes.
Okay, whatever you guys can do, that would be best. Okay.
Okay.
All right. Now, again, this is going to be video recorded. Homework questions will be video recorded. You know, I'll even do a pre-lesson that's video recorded, so you have lots of times to refer back to things in case you don't get them the first time through. All right. Now, it's a bit of a weird situation for me because really we're going to start a brand new unit and a good one. We're going to start calculus. The problem is the start of calculus takes a little while to get going. So we're going to take our time this week. And what I'd like you guys to do as a part of your homework is two things. Well, one is this rates of change, right? You can look at the assignment. Just, that's you guys. Sorry, the instructions are here. There's just a couple of questions to work on the attached worksheet. I'm going to attach it there for you guys to do. I guess I didn't put that in. But you also have another homework question to do. Let me see if I can get back to the stream here, to the classwork. And that is another Desmos classroom. This one's called Mr. Skiff and Il Ponte dei Salti. And I want you guys to do this at the end. We might finish early and you can start that already. I'd like you to start this as soon as you can and have that ready for next day. So don't do it right now. Give me about 15 minutes to talk to you and then you can start it when we're done. When you finish that tomorrow, I'm going to put together a presentation for our next class meeting on Wednesday, and we'll take a look at that. Is that clear?
Mm-hmm.
Okay. It's a good one. It's about 20 slides long, but it gets us just about ready to talk about a bit of calculus, okay? So you got two little things to do for next day. One is this exercise, and then there'll be some homework exercises here, which I think actually are attached also to this information, okay? So what we're gonna do right now is take a look at this. Did you guys get a chance to print this off? The rates of change notes?
No.
Yeah.
How many people got it? I see Mateo's got one there. How many people are still not? Hands up right now if you don't have that. Yeah, okay.
To print it.
All right, so just follow along with me and then you can go print it at your leisure. I'm gonna annotate some notes and then I'm gonna upload them back up here so you can just follow along and answer questions. If you wanna write some things down on a piece of paper, you can, okay? But in order for me to do this, I'm gonna change the share and I'm gonna go and share to my iPad. And this is one of the reasons why I really like this Zoom. Okay, so let's just let this, okay, we trust the iPad, yes we do. Okay, radio, can you guys see the sheet here?
Yeah.
Okay, this is dead easy. You're gonna find this super easy little thing to work on and then we'll take up any last questions you have and then you guys can go your way and you can start working on the teacher Desmos, yeah? Anyway, what we're really looking at, how many people know a bit about calculus anyways? Anyone know anything about calculus out there? Victoria, what do you know?
Did something last year.
Yeah.
No.
Victoria, what do you
Limits.
know about calculus too? You can share with us.
Hmm?
What is it that you know about calculus?
Well, I don't remember much, honestly.
Don't remember much? Who can say a little bit about calculus that they know? Will?
Limits.
Limits, yeah, George, yeah. Will?
Well, I mean, like,
derivatives and the chain rule, power rule,
yeah, like implicit differentiation, integration, chain
quotient
rule,
rule.
product rule, all that kind of stuff.
Okay, Ludovico, what about you? Do you know anything about calculus?
No, limits.
No? Limits, yeah. Okay, well, we're going to get into a lot of what you talked about, but first I want to back up to the beginning of calculus. Calculus is really about rates of change, right? That's why there's this note called rates of change. Basically, a rate is a comparison between two quantities of different kinds, okay? Hey, the rate that's been out there a lot are the number of coronavirus virus cases per million people in the population. So number of people who diagnosed positive divided by the total number of population, okay? Have you guys been looking at any of those statistics recently?
Yes.
Kind of.
Highest in the world, you know where it is right now?
Of active cases?
Active cases per million people is the statistic that's out there.
Italy.
Italy, yeah. Second highest,
Spain?
China.
Switzerland.
Iran. Switzerland.
Switzerland,
Damn.
Switzerland just came up
million.
second highest, and I don't know what the rate is for Ticino. That's all in Switzerland. And anyways, those are rates. And what we'll look at is we'll just turn this over to something a little less about coronavirus. This graph here is showing you the relationship between the total costs in millions of euros. So that's up here on this axis. Okay, so this could be like 1 million. And the number of cars in hundreds. So these are number of cars in 100, okay? And again, I'm going to save this and put it up onto the Google Classroom, so if you're not writing things down, don't worry about too much, okay? And so this is like 1, 2, 3, 4, there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, and 25, okay? So if you look at the graph, you don't really need to write anything down here. If you look at this graph, what does this graph tell you about the relationship between the number of cars produced and the total cost of production?
It is the most convenient to build like a medium.
Somewhere in here is more
No.
convenient, Ben?
Yes.
Yeah.
What does it tell you about the relationship? What would you say the relationship's like?
Direct.
As the number of cars increases, the expenses increase.
Yeah, that makes perfect sense, right? You want to build more cars, it's going to cost more. Yeah. Can you be a little more precise? Because Ben was kind of focusing on this part of the graph here. How do the things increase?
Mm.
It's like an x cubed function.
Okay, it looks like it could be a cubic function. It definitely.
They don't increase in proportions, like the actual.
It doesn't increase in proportion. What do you mean, George?
Like what I mean is, for example, it's not like you increase one and then in proportion increases the other. It's like
No. No, if that were the case, what would the graph look like? If it,
straight line.
yeah, it'd be a straight line. So the curve is telling you that they don't increase proportionally, as you said. So how do they increase at first? What would you say here?
Well, it's like
If you had these words
like
fast or
if
slow,
it first drops,
Rhythmic.
then it's sort of like
Like a radical.
slow down, gradual increase, and then rocket it again.
Logarithmic and then exponential.
okay,
Yeah.
logarithmic or exponential, or George was saying it increases, but it slows down, right? And then over here, it starts to increase a whole lot more,
So
right?
can you say it's like a rate of growth or no?
Yeah, it's a rate of growth. So we can measure the rate of growth by looking at a secant line. So a secant line is a line that touches the graph at any 2 points. And I've drawn some in here for you. Let me get a better color like green, right? So here's one secant line. Here's another secant line. And these are other, oops, secant lines. You can see them there, okay? What do the slopes of the secant lines tell you about the way in which the costs increase? If you look at the slopes of the secant lines. Oops. Look at the slopes of these secant lines. What are they like here?
The rate of change.
Okay, they're telling you sort of a rate of change. Why is that, Ludovico?
Well, because it's like an average of the curve, I think. Like
An average of the curve. You're close. What's it an average of? What you said slope, right?
Yeah.
So if we measure the slope, it's the change in the y. What are we measuring on the y-axis in this graph?
The million.
Well, so
It's
It's
the
like
change in euros, right?
Yep.
And on the horizontal axis, what are we looking at?
The production, the number of
cars.
Call it N for number of cars, and let's say C for costs. So this is the change in C over the change of N.
Mhm.
Yeah? right? So if you look at that, here it's really high. There the slopes are smaller and smaller, and then they get high again. So what does that tell you about the way in which the costs are going up?
Like they go up fast at the beginning,
Mm-hmm.
and they're like stable.
Yeah, so the slope is telling us, in a way, the rate of change, right? It's kind of, this is a measure of the rate of change. So at first, the rate goes up fast, then it slows down, and then it goes up fast again, right? So if we had to describe how the cost changes, production rises, we'd say, okay, costs go up as n goes up. But at first, that increase is slowing down, as you guys said. So let me just highlight a bit. Well, I guess this thing works pretty good. Slows down, and then it starts to go back up, right? So we would say that the cost increase, somewhere about here, they increase at a decreasing rate. Call that part one.
Professor, can you zoom a bit?
Oh, you can't see?
Yeah, it's not very clear.
No?
Yeah, it's kind of like pixelated or something.
Yeah, I don't know why, but it's a bit
Yeah, it's
blurry.
blocked on my end. That's why. My iPad's, how's that? Is that better?
Mm-hmm.
Yep.
Yeah.
Yeah, somehow the iPad was stuck. I couldn't even change the zoom. I think that was the problem. How's that? Is that okay?
Yeah.
Yeah.
Okay.
Yeah.
So then the second part over here, though, that first is part one. Part two, those costs increase at what kind of rate would you say? Increasing or decreasing rate?
Increasing.
Yep. So the increase, stuck again. I know that might be pixelated for you. Just give it a sec. There we go.
Ooh, Vinny's back.
At an increasing rate.
Oh, Vinny joined.
Vinny. Let's let him catch up. Okay.
He's
So
muted,
there's
though.
6 ways, guys, in which we can talk about rates of change. Okay? How would you guys match these up? Take a second right now. For each one of these numbers, there's a corresponding graph and only one graph. Which one of these ones would you put with that? Take a sec to do that on your own. Which one would you say is increasing at an increasing rate? Which letter goes with that one?
F.
Yeah,
Yeah.
definitely.
Yeah.
Right? This is the whole fear with the current outbreak of the coronavirus, is that it's going to increase, but it's increase at an increasing rate. What was it, like yesterday in Italy, there were 3,000 new cases all of a sudden. Well, hopefully it's going to turn into something like A. How would you call A? So this goes with F. Which number did you put with A?
Increasing at a decreasing rate.
Yeah, that's A. So it's going up, going up, going up, but then it's not going up by very much towards the end. So which one then is increasing at a constant rate?
D.
That's easy. Right? That's what you were saying, George, proportionally or at a constant rate. Okay? Now, of the decreasing one, which one is decreasing at a constant rate?
E.
Sure enough. Okay. Which one decreases at an increasing rate?
B.
B.
Yeah,
Yeah,
sure.
B.
Think about being on a roller coaster, right? This first little bit wouldn't be much fun, right? But then, or if you're skiing, right? You're the vehicle, you're the skier of the group. This bit here would be a whole lot more fun to ski down than the first bit, right? So this is going to go with number 5, and that leaves C to go with decreasing at a decreasing rate. So it'd be a lot of fun at first, and then it would slow down at the end. Okay, good. All right, so let's put a little bit of mathematics to this, and that is if you turn the page over, that's the average rate of change. So when we're looking at these secant lines, and we're measuring the slope, what we're actually measuring is called the average rate of change. You're taking the change in the y, and you're dividing by the change in the x. Okay, so if we had a change, for example, of, who knows, 500,000 euros, and we increase production by 2,000 cars, then we would have an average rate of change. Well, what would that be if we take 500,000 and divide it by 2?
250.
250. What would the units be on that if we were doing the euros and the cars? 250 what?
Cars.
Euro per car.
Yeah, euros per car. Okay, so the average rate of change is giving us some measure of how things are changing. So remember, the rate is a comparison of two different quantities. So the euros are going up by this much per car, right? And this is defined to be the slope of the secant, because if you have the function, say, f of x and x, the slope here is telling us from P to Q how much the y is changing per unit change in x. Make sense? And you're going to work with that today, later on when you do the Desmos activity, and also when you're working with the homework. But let's just get a little practice here. Okay? So the average rate of change is represented geometrically by the slope of the secant between the 2 points. Let's pretend that this is a colony of rabbits. Okay, let's put some units on here. We got to go up to 20 weeks. So I believe each one of these represents one week. Okay, and this can represent, now if I put one rabbit there, you're going to be a little confused as to how one rabbit became 2. So let's say these are pairs of rabbits. Okay, is that all right? Either that or we could scale it by 2. Why don't we do that instead? Let's just say this is the number of rabbits, and this starts at 2. Yeah, otherwise, how are you going to get more rabbits? You know what rabbits are like? As the time passes, they start to reproduce, and we get a curve like this with the number of rabbits. So here we have number of rabbits is going up over time. How would you describe the increase?
Increasing at a decrease.
Increasing rate.
Up into somewhere, say here, how would you describe that increase?
Increasing rate.
Increasing rate, right? And then what happens?
Increasing rate.
Decreasing rate.
Increasing at a decreasing rate.
And then?
Yeah.
Decreasing.
Decreasing.
Kind of hard to tell, but it goes down, right? Maybe the population gets too big for the environment that they're in, and they start to die, or some predators come like wolves or foxes, and the number goes down. Use the graph to estimate the average rate of change in the rabbit population in the first 5 weeks. Okay, so 1, 2, 3, 4. There's your 5th week. What would be the average rate of change in the first 5 weeks? How would you measure that?
Well, you'd like have to calculate the gradient over tangent, basically.
It's like rise over run.
Okay, so we could do a secant line, and we're trying to measure the rise over the run.
Yeah.
What's the rise?
4.
2.
Well, 2 spots are 4, right? Because remember, we want to count them as pairs. 4,
Yeah.
and the run is?
5.
5.
So what would that's 0.8. What would that represent? 0.8 what?
4
Rabbits per week.
Week.
The rabbit population is going up at about 0.8 rabbits per week. Yeah, you can't get 0.8 of a rabbit in a week, but there's some baby rabbits on the way after 1 week, okay? After 2 weeks, there's a whole rabbit and 0.6 of a rabbit on the way, okay? What about from the 5th to the 10th?
Okay.
So now we can call this graph f of x. Yeah, and x is down here. What we're looking for is f10 minus f5
26.
over 10 minus 5. How many did it go up by?
10.
26.
1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's 10 spots here, We don't count the 3 down below. We only count
Um,
increase in 10, right? Which represents 20.
Yeah, I got 20.
So it's 20 up.
So 4.
Yep. So there's
Yeah,
now
4.
4 rabbits per week. You get it? Okay.
Yep.
From the 15th to the 20th week. So 11, 12, 13, 14, 20. Hey, what happened there?
There's a
Now,
double square.
what's that? Well, the formula says do F20 minus F15 over 20 minus 15. What happened there?
Uh,
Well, what was the change?
there's 1.
I can't hear. We got cut off there.
1.
1? Well, you think it goes up by 1?
No. It goes up by 0.
Okay. 0 over 5. So the formula would say 0 rabbits per week. Now, you guys were a little uncertain to put that down. Why? What's the big deal? It's kind of misleading, isn't it?
Actually, it's
Yeah.
going up.
Yeah.
George, why is it misleading?
By looking at my graph, because I cannot see what you wrote there.
Oh, you can't see what I wrote?
No, but I think it is misleading because it still grows. But if we count at 0, yeah.
Okay, so here's the problem with the average rate of change. It's like you open your eyes, you count the number of rabbits, you close your eyes for 5 weeks, you open them up again, it's the same number of rabbits. You missed the little bit of growth that took place and then a little bit of decline that went down, you see? This is a problem with the average rate of change. It's like 2 snapshots. What's it like today? What's it like in 5 weeks? No change. Therefore, the average rate of growth is 0, but that doesn't mean that something didn't happen when we had our eyes closed for 5 days. You got it? So average rate of change is a bit misleading. In fact, what if someone said to you, why don't you find the average rate of change over the entire period? Okay? Now what would we be looking for?
Just the start and the end.
The start
In
to
the
where?
end.
To the end. So we would go, okay. So let's see, that's 21, 22, 23, 24, 25. It ends at 26. So we'd be looking at F26 minus F0
4 over 5. No.
over 26 minus 0. So over the 26-week period, what happened? What's the increase?
26 or 25? 26.
Is it 25? Are you saying I counted wrong, Ben?
I don't know. It's 25. It's 26. Sorry.
I think it's 26, yeah. And then, so how much did the rabbit population grow by? Well, it started here at 2, 6, 8, 10, 12, 14, and it ended at 18.
So 16, right?
16, right. Over 26. And we could simplify that. It's what, 8 over 13? And, oh, do you guys have your calculators? Does anyone know?
It's about 0.650.
0.65?
Yeah.
0.57.
0.615.
No, sorry.
Yeah.
615?
615.
Yeah, 615.
Okay. How about 0.62? Oh, wait, 3 significant figures, right?
615. It's fine.
Okay. So that would tell you that the average rate of change, whoops, my iPad's stuck, for the whole period is about 0.615 rabbits per week. But why would that be misleading?
Because it ignores the peak.
Ignores the peak, yeah? What else does it ignore? Was the rate of change always about 0.615 the whole way along?
No.
No.
No. It was really big here, and it was lower actually than 0.615 here, and actually it was negative over this portion. And that's because, again, we're taking the average rate over such a long period of time. Yeah? Matt, you got a question, dear? Sorry.
Yeah, I don't really understand what's happening from the 15th to the 20th week. So the average rate of change is 0, but the there's still growth?
There's
or-
still growth over that period, but since we're taking the
But-
average rate of change, on average, it's as if nothing happened. Okay?
Oh,
There's also death.
but there was a growth and then there was a decline, right? So
That's right. But the
Okay.
average rate of change doesn't take those two things into consideration. It only looks at those 2 points in time and says, hey, the population was the same. It misses what happens in between.
Okay.
Yeah? So
Thank you.
what I'd like you guys to do, any other questions about that? There'll be two
No.
really easy exercises to do. I need to post a worksheet up for you guys. It looks something like this, okay? These are from the Hayes and Harris book, but I just put them on a worksheet for you. I want you to do some of these questions. They're pretty straightforward. You can start on that right away, but most importantly, I'd like you guys to take a look at the Desmos.
Mr. Chef one.
Yeah, I'll show you what you're in for. Okay, if you guys can do that for next day. Let's see, what are you looking at? You're looking at this right now, right? If I go here, I think you should have the code on Google Classroom in custom. Still slow here. Let's see. Here we go. Mr. Skiffen and Ponte dei Salti. Do you guys know the Ponte dei Salti?
No.
No?
What's that?
Well, it's in the Valle Versasca, not so far from Locarno. It's a bridge, yeah?
Okay.
People go there and they jump off, you see? And so in this particular one, there's a video to play. Just click down here. Turn the volume down. The fun stuff's at the top. Mr. Skiff's gonna jump off this bridge.
Yo, we should all go do that.
Well, it's kind of cold now, you know?
That's pretty fun.
Yeah, in the summer, in the summer.
And there he goes.
Yeah, Anthony, let's go.
Huh.
Let's go.
Yeah.
And your
Let's
job
go.
is, well, I did some of the work for you. I did on that video our famous app with the dots. You see that?
Ah.
And you got some questions to answer there, but I took the data and I plotted it for you. Okay. And so what I would like you guys to do is answer the questions involved in this, and we're going to try and figure out how fast Mr. Schiff was going down when he dropped after 1 second.
Okay.
Is that clear?
Yeah.
Do you guys have any other questions?
Yeah, Miss, sir, sorry, you said that we would have work every day.
Not work every day. Work before the days that we meet, right? So I think 3 or 4 days a week you'll have some work to do.
Okay.
But we won't meet every day. We're going to meet 3 out of the 4 days.
Okay.
Any
Wait,
other?
miss?
Yep.
I also found this simulation exercises cylindrical tanks. Do we have to do that?
What's that?
Simulation exercises cylindrical tanks. It was attached with the notes.
No, don't, just ignore that. Yeah. Was it attached to the sheet that you downloaded? This bit here, right? You're talking about?
Yeah.
Yeah, don't worry about that.
Okay.
Let's just show everybody what that is. So what Natty's talking about is the worksheets you're working on. There was a couple more pages. Yeah, no, we're not going to do those here. Okay?
Okay.
You can just, we're going to assign a couple exercises from here, and then you work on the student Desmos activity for Wednesday.
Okay.
Is that good?
All right.
Let me see your faces before I cut off. Yeah, we're good? Any questions?
Yep. No.
Oh, sir.
Okay, so Vinny, are you okay over there?
Yes.
Okay, can you hang on, Vinny, because you missed the first bit. And everybody else, I'll see you guys on Wednesday. If you have any questions, email me, okay?
All right.
Okie dokie.
Thank you, mister. Bye-bye.
Guys, have a good
Peace
day.
out.
Bye.
See you later.
You too. Have a good one.
Ciao.
Bye-bye.
Okay, Vin, just hold on 1 sec, okay?
It's okay.
I'm gonna stop the recording here. So I recorded everything.